Let's take a look at compression here. And this is the way that we take photos and video and audio and any type of file and shrink it down into a smaller space. So compression, like I said, is it reduces the amount of data required to store something. And without compression, modern computing would be nearly impossible. The file sizes would just be too large. Like if we had to save every letter, every pixel, everything as is, just with a number all by itself, we would have, completely massive file sizes. And you might have seen this in the introductory activities, seeing how big those files could get. When we look at compression, there's two main types that we look for. So we've got something that we call lossless compression and something that we call lossy. So lossless and lossy, and those kind of hint at what each of those compressions do. So firstly, lossless compression compresses data without losing information. It's lossless. And two examples of this. I've got run length encoding and block encoding here, and the idea behind both of them is if you have some file, so imagine we have a picture here, and imagine it's just a picture with a bunch of stripes of colors. So we've got a red stripe here, and then we've got some blank stripes, and then let me grab just a different color here. We'll do this dark blue that you can't see. So we'll change that to the light blue here. So if it's got a bunch of things like this, there's no reason that the file has to have a bunch of identical symbols over and over and over again if there's this repetition. And so what we can do is there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So it might be something like we say 9, and then the numbers that you would use for black. And then we would say 9, and then the numbers you'd use for red. And then 9, and then the numbers you use for black. And then 9, and then the numbers you use for blue. And this means instead of having to have 9 numbers here, or 9 sets of numbers, you only need 2 sets of numbers in this case, because you've got the leading number to tell you how many, and then the description of that. And this works if there's large repeated chunks like this, because you can see that that it reduces it quite a lot. Now, if it was 1 and then the number, 1 and the number, and it was all alternating, this wouldn't work so well. The other way that we have is block encoding, which instead of saving this in, just saying the list, it will subdivide it into blocks. And it'll look for patterns or similar types of blocks. So we might have like this block with black on top, red on the bottom. And we might have one that's black on top, blue on the bottom. And you can imagine how this can then be encoded, where if you give some number, like you call this one block of the red on top, black on the bottom. So I'll just label black, black, red, red. And you call that a 1, then you can say, put 1, 1, 1, 1, 1. And then if this other type is 2, 2, 2, 2, 2. So you can look at, imagining looking for patterns and compressing things like that. So those are the two ideas. One just kind of on the single pixel level, or the single type of information. If it repeats, labeling it. The other involves looking for clusters or chunks that are similar. And that's the basic idea. You don't need to worry about details, but that gives you that sense there. So now if we look at lossy compression instead, lossy compression compresses data while losing or discarding information. And so this could be bad if you're losing in data that's important. So ideally, the information that's lost is unimportant. And that might seem weird, but if we use this in audio and pictures, human hearing is imperfect, and human vision is imperfect. So if we're recording something and saving it for us to look at later or to listen to later, we don't need all that information for us to get the impression. Like, there might be information that we don't even perceive, so we can lose that. And so, for example, with hearing and audio, all super and subsonic frequencies can be removed. So there are sounds that the human ear can't hear, like no matter how good your hearing is, it's just, above or below our range of hearing. So if you record in a studio, you get a bunch of that information, you can throw that away. Like, you can choose to get rid of stuff we know we're not going to need. Or you can get rid of, some of the really fine detail that, most people aren't going to notice or care about. If there's various, quiet sounds that wouldn't normally be heard. This isn't actually how it works because it's more complex and math involved, but there are basically ways to get rid of either really quiet sounds that you don't care about, or to kind of take everything and make it take up less space. Same thing for example, JPEGs. So those are common picture files, and those are compressed with lossy compression. And what a JPEG basically does, and this is again a vast oversimplification, if we have something like this, and imagine we've zoomed way in on our picture. So this is a tiny, tiny patch of however many, 16, 20 pixels this is. So maybe the pixels are, something like this. And what it might do is save that as, instead of 16 pixels, it might reduce it down to 4 pixels, and just group them together and say, what's the most common color we have here? And just say, that pixel should be like that. So if you looked at it and ignore this last column, these two pictures, if you imagine zooming out, they're going to look practically identical. Because, it's a mostly black spot, then a mostly red spot, then a mostly red spot, then a mostly black spot. This is an oversimplification of how image compression actually works when it's lossy, but it's the general idea. We get rid of details or information that's not going to be noticeable to the human eye. That's the ideal, and then that results in what we have. But what can happen is if you compress over and over and over again, it might think details that are unimportant. It might think important details are unimportant, and that's where you start to see things get pixelated or blocky or look kind of funny. So that's the idea behind compression. It's just taking an audio or taking any type of file and looking for patterns and using those patterns to record the information in a more compact fashion.